Okay, so last section for this week. Sorry for the delay, but it's my birthday and my family had a birthday party for me, so it took me a little longer to get here. So yesterday's section was adding probabilities. Today we're multiplying probabilities, and the big difference is yesterday's stuff was or, and today we're going to be looking at things to happen at the same time. So one thing happens and another thing happens at the same time. So there's independent and dependent events here, where if something matters, like say we are pulling pieces of paper out of a hat, and we're going to pull 5 of them out, and each time we keep the paper out, the probability of the second, third, fourth, and fifth will change because there's less things in the hat. So dependent events, when the sample space changes for the successive items, it's a dependent event. If everything that you're picking, the probability of each item doesn't depend on anything else, then we can do the simple probability where it's just the probability of the first thing times the probability of the second thing. When you have a dependent event, it's the probability of the first thing, and then the probability of the second thing when you consider what happened to A in the first item. That's called a conditional probability. So our conditional probability here can be given as the probability of both things happening over the probability of the first thing happening. And sometimes that's the best way to think about it, and sometimes you can just think about the situation and give B given A. So we'll get to that here in just a minute. Example 1. Decide whether the events are independent or dependent, and then find the probability. So we have to choose. Mainly we have to choose because we need to decide what we're doing, but you also need to say, is it independent or dependent? Then find the probability. Okay, we have 2 dice, red and blue. What is the probability of getting a 3 on the red and a 5 on the blue? So we have red. Just picture here what's going on, and we have blue. So if we roll a 3 on the red, will that affect in any way what comes up on the blue? No, they're totally different things. They're not related. It's not like if we roll a 3 there's more sides to the blue. So we need this to happen. So what are the probabilities? Well, it's going to be independent. So we have to use this, the probability of A times the probability of B. So the probability of getting a red, this doesn't tell us actually how many sides are on the dice, but we always assume it's a 6-sided dice unless they tell us differently. So rolling a 3 on the red will be 1 out of 6. Because we're rolling the red dice and there are 6 choices. Rolling a 5 on the blue, we're going to multiply that, will be 1 side out of the 6 sides on the blue dice. We want both of those things to happen at the same time, so the probability of that is when we multiply their probabilities, and we get 1 over 36. Okay, next one. A bag contains 8 blue, 6 red, and 5 green marbles. 3 marbles are drawn 1 at a time. So we're going to draw 1, 2, and 3. Draw 1, draw 2, and draw 3. Find the probability that the second marble is green, given that the first marble is blue and not replaced. Okay, we want to know just the So we have 1, 2, and 3 things being drawn. I did not realize that I was off the camera. There we go. We just want to know the probability that the second marble is green. We actually don't even care what happens with the third marble. So find the probability the second marble is green given that the first marble is blue and not replaced. Replacement is a huge deal with these problems. You have to decide, was it put back or was it left out? So let's talk about the first marble being drawn. What is the probability that the first marble is blue? Well, we have 8 plus 6 plus 5, or 19 marbles, right? Okay, this is very clearly a dependent event. Dependent event because it was not replaced. So the first draw, there are 19 marbles, and how many of them are blue? It's 8. Okay, so that is the first draw. The second draw, we can use the, and you can't see it now, but the probability of B given A is probability of A and B over probability of A. So for this case, the second draw, would be probability of A and B, which is blue. Where's it at? Blue and green. Those are the colors we're looking at. So we didn't replace this blue, so now we only have 7 blue and 5 green. Make sure this is right. Yeah. So this would be probability of blue and green over probability of blue is 7. Okay. And blue and green was 7 plus 5 is 12 over probability of B, which is, oh no, blue, which is 7. Oh, that's a mess. Okay, yeah, this is just going to be confusing. Think about the situation. For item 2, if we did not replace this marble, how many marbles are left? 18, right? 1 less. So in those 18 marbles, what are we choosing from? Well, we took one of these away. So there's 7 blue left, 6 red, and 5 green. So if the second marble is green, means we're going to pick a green marble. There's still 5 green marbles to pick from, but the total is reduced because we did not replace. So we're going to give an answer here. They just are asking about the probability of the second marble. They don't care about the whole event. So your answer here is the conditional probability, what happens in this second event, given that the first happened. So the answer here is 5/18. I think the simplest thing to do is think about the situation. Okay, and we'll see that again on the back. So we'll see another example like that. Alright, example 2. This is a frequency table. It's called a frequency table, a two-way frequency table, because this table shows Mr. Diaz's class how they fared on their first driving test. Some took a class while others did not. Find the probability. So there's a bunch of kids, and we want to add some information to this table. I think is the easiest way to do it, because we want to be able to know at one time how many kids passed the class, how many kids, or the test, how many kids failed the test, how many took the class, and how many just winged it and didn't take the class. So we're going to add all these together and get our totals so that we can easily find these probabilities. So how many took the class? 64 and 18 took the class. That's 82 total kids. How many didn't take a class? 80 of the kids did not take a class. All right. How many passed the first time through? 112. Just adding these. And how many failed? 50 of them failed. So no matter which way you add these, there were a total of 162 children who took this driving test. Whether we talk about passing and failing, or whether we talk about who took the class or not took the class. Okay, so these questions here are asking you, like up here, conditional probability. They're asking you about the conditional probability. Okay, so for the first one, we want to know if Paige passed, given that she took the class. So we're looking only at kids who took the class. So this first column, how many kids passed if they took the class? 64 passed, and the total number of people who took the class is 82. All right, then, oh shoot, we have to go back for a second. But then we have to reduce. You always have to reduce if it's reducible. So these are divisible by 2. So this will end up being 32 over 41. Okay, we only want to know what is the probability that, assuming she took the class, what's the probability she passed? Okay, second situation. Madison failed given that she didn't take the class. So assuming we didn't take the class, how many kids did not take the class? That would be 48 and 32, or 80. How many of those students failed? 32. So when we reduce here, they're actually both divisible by 16. So eventually you would get down to 2 over 5. All right, there's one more here that I think flipped over. Yes. So Jamal did not take a class given that he passed. So if we come back over to our table, now we're looking this way. Look at the students who passed. Total students who passed is 112, and we wanted to know if he did not take the class. That's 48. So that probability, there were 112 students who passed. 48 of them did not take the class. So we need to reduce this. We could divide by 4, and then it's divisible by 4 again. If you reduce that, you will get 3/7 chance that he did not take the class given that he passed. Okay, really quickly, back here, we forgot, what if it was replaced? So how does that change the problem? Replaced. Well, we have the 2 marbles that we're drawing, right? Find the probability the second marble is green, given the first marble is blue, and replaced this time. So the first part is still the same. There's still 8 out of 19 chances that you're going to pick out a blue marble. But if we take the marble and we put it back in this bag, or yeah, the bag, there are still 19 marbles in that bag now. We put it back. We want to choose a green. There were 5 green, so it changes your denominator. If it isn't replaced, it's 18. If it is replaced, it goes back to 19. Okay, so sorry for that being a little backwards, but hopefully that makes sense. Example 3 is 3 marbles are drawn from a bag with 8 blue, 7 red, and 5 green. without replacement. We're not going to do any replacement on any of these problems. So we need to find A is the probability that you get 3 blues. So we want the chance that we get a blue, and a blue. Okay? So if we have blue, there are a total of 8 blue marbles. And how many altogether? 8, 7, and 5 is 20. So we have to think about the probabilities. Now we want this one specific option. So we are going to take the probabilities and multiply them together, because we want to know these 3 marbles, what's the probability of getting all of these together? Not just one specific part, like we asked about in here. Probability that the second marble is green. Okay, so pay attention to what they're asking you for. But it's the same kind of thing to come up with those individual probabilities. The first marble has 20 possible options here. So how many of those are blue? There are 8 out of 20 that are blue. Now the second marble, we're not replacing that first one. It didn't go back in the bag. So there are only 19 marbles left. And how many of them are blue? There were 8. We stole 1. So there's only 7 blue marbles left. Okay, for the third marble, we didn't put either of those 2 marbles back. So there's only 18 left. There were 8 blue to begin with, and we've already taken 2 of them. So there are 6 left for our third marble to be chosen. Then you just multiply these out. So do what you need to keep it clean, but you could do 8 times 7 times 6, 20 times 19 times 18, and write what that equals. I don't think I did that. So, and I didn't bring my calculator. I just did the reduced version. So 8, 7, and 6 is 336 over 20 times 19 times 18, 6,840, and reduce that with your calculator. Use your tools that you have. That will be 14 over 285. And for all of your probabilities, I would like to see these as a whole fraction. I don't want to see decimals. Okay, so use your tools to give me the reduced fraction. Alright, then, okay, just in case that's showing on yours, then we have 3 marbles again. We need a blue, a green, and a red. Okay, so when we start out, I just like putting it underneath because there's more room. We start out, we have 20 marbles, right? We're going to pick a blue. How many were blue? 8. The second marble is green. We didn't put this blue back, so there's only 19 marbles left to pick from. How many greens can we choose? 5. We didn't put the marbles back, so we still only have 18 to pick from. And now we're picking a red. There were 7 red, and we haven't chosen any yet, so it's going to be 7 there. So when we multiply these out, you're again going to have 6,840, but on the top, we have, what, 40 times 7, or 280? And this reduces to 7 over 171. Okay. So pay attention to whether things are being replaced or not. That's very important. And in some of the problems, they're not going to ask you for the whole event like we did at the very last one. They're going to ask you for either the first one or the second one or the third one only. So read very carefully and make sure you're paying attention to what the question is asking. Okay, good luck. Turn in your assignment. I'll be giving feedback as soon as I can. And I will also post the worksheet so that you can begin on that. However, it won't be due until Wednesday of next week. Tuesday of next week we'll be doing section 0.9, and then I will also put the worksheet out there, but I just want to give you guys plenty of time to work on the worksheets on your off days. Alright, have a good weekend, and I will see you next week. If you need additional help in like a Zoom meeting setting, please send me an email, and if need be, I will set one of those up. Thanks, guys. Bye.